Hello, welcome everyone to this lesson. In this lesson, we're going to focus on the measures of spread. Let's start by reading our learning objectives. The first learning objective is to be able to compute and interpret the standard deviation given a data set. The standard deviation is going to help us measure the spread of the data set. Our second learning objective is to be able to describe data sets using the standard deviation. For example, we're going to use the standard deviation to help us measure how far a data set is from the mean. And the last learning objective is to determine if a data set contains an outlier using the standard deviation. Now, previously we talked about the measures of center. We used the mean, median, and mode to describe the center. In this lesson, we're going to focus on understanding the variability, which is the spread of the data set. We're going to focus on the most common measure of variability, which is the standard deviation. The standard deviation is going to be a value that is a measurement of how much the data varies around the mean. Now, with that being said, would you be able to look at the graphs here below and determine which data set has the highest standard deviation? Remember, the standard deviation is going to indicate the spread of the data set. And so if we see a bigger spread of the data values within a data set, then we're going to expect a higher standard deviation. So if you're looking at the histograms here below, which histogram has the highest standard deviation? In other words, which histogram has the highest spread? The answer to this question is the histogram on the left. The histogram on the left has the highest spread. Thus, we expect the histogram on the left to have a higher standard deviation, or to have a higher standard deviation than the histogram on the right. The higher the spread, the higher the value for the standard deviation. I wanted to do this exercise to help you make the connection between spread and the value of the standard deviation. Now, let's go ahead and focus on finding the standard deviation. Here below we have two formulas. One being the formula to calculating the population standard deviation, and the other one being the formula used to calculate the sample standard deviation. For the population standard deviation, we use the Greek letter sigma. We're going to see this Greek letter throughout the whole quarter. Make a note to yourself. When you say sigma, you should know that this represents the population standard deviation. The population standard deviation sigma is calculated using the formula, the square root of the sum of x minus mu squared divided by n. Here, x represents a data value. Mu, which is something we have seen before, mu represents the population mean, and n represents the number of items in the population. So what are we doing here? For each of the x values in our data set, we're going to compute x minus mu, and then we're going to square that expression. We're going to do that for each data value. Once we're done calculating x minus mu divided by 2 for all data values, we're going to add those values. Then we're going to divide it by n, which is the number of items or individuals in the population. And once we're done computing that, which is the expression inside the square root, we're going to take the square root of that value. Now, in this lesson, we're not going to compute the population standard deviation because we don't have data coming from the population. And this is going to be the case for the whole quarter. We're not going to have real data coming from a population. Remember, statistics are computed from looking at a sample, and so that is the focus of our class. Now, we are going to compute the standard deviation for the sample. We use S to denote the standard deviation for the sample. We use a different letter, that way we don't confuse the sample standard deviation with the population standard deviation. So we're going to use S to denote the sample standard deviation. Here, we're going to be computing the standard deviation by taking the square root of the sum of x minus x bar squared divided by n minus 1. Here, x represents a data value, x bar represents the sample mean, and n represents the number of items in the sample. We're going to take each of our x values and we're going to subtract x bar. Then we're going to take the square of that expression. Once you do that for each x value, you're going to add all those squares. You're going to add all those values, and then you're going to divide by n minus 1. Once you get that value, you're going to take the square root of that value. In this lesson, we're going to compute the standard deviation by hand, and then we're going to compute the standard deviation using technology. Before we compute the standard deviation of a data set, I want to make a few remarks. When we talk about the deviation, we are referring to the distance between a data point and the mean. If you take one of your data values and you subtract x squared, the value that you get is known as the deviation. This represents the distance between the data value and the mean. In practice, you might hear someone talk about the variance, which is why I want to mention it here. The variance is going to be the sum of the squared deviations divided by n minus 1. In other words, the variance is equal to, and I'm just going to write it here, the sum of x minus x bar squared divided by n minus 1. So notice, the variance is the expression inside the square root. In other words, it's going to be the expression you get before you take the square root. We use sigma squared to represent the population variance. We use x squared to represent the sample variance. Again, think about it. The variance is the expression inside the square root. If you have s, this is equal to the square root of the variance. Thus, that means that the variance is the square of the standard deviation. Now, in this class, we're not going to use the variance to describe the spread. We're going to use the standard deviation. Now, we're going to focus our attention on learning how to compute the standard deviation by hand. Once we compute the standard deviation by hand, we're going to compute the standard deviation using technology. After we're done with this exercise, I have another exercise where you're going to be computing the standard deviation on your own. So let's start by doing an exercise together. Here below, we are going to consider the data set 3, 5, 6, 6, 7. If we're going to compute the standard deviation, we first need to find x. To find x bar, we need to add all the data values and divide them by the number of data values we have. On the numerator, we should have 3 plus 5 plus 6 plus 6 plus 7. And on the denominator, we should have 5 because we have 5 data values. Go ahead and find x bar. You should get 5.4. So now that we have x bar, we can move forward to completing the table here below. Notice here on the first column, we have all the x values, which are the data values. On the next column, we're going to be computing the deviations. And then on the next column, we're going to take the square of the deviations. Notice, we are focusing on this first part of the equation. We take each of the x values minus x bar, and then we square. So let's go ahead and do that. For the first x value, which is 3, we're going to have 3 minus 5.4. We get negative 2.4. Once we have x minus x bar for this first value, we need to go ahead and square that expression. So I'm going to go ahead and do it here. We have negative 2.4. We need to go ahead and square this value. We get 5.76. Make sure to place parentheses around negative 2.4. Why? Because you want to take the square of negative 2.4, not just the square of 2.4. Let's move on to the next x value. We have 5 minus x bar, which is equal to negative 0.4. Now that we have the deviation for this x value, we need to square the deviation. So let's take negative 0.4. Again, parentheses are needed. We're taking the square of this deviation. Negative 0.4 squared should give you 0.16. Let's go ahead and do the next two data values. We have 6 minus x bar, which is equal to 0.6. I'm also going to do the next x value, which is also 6. 6 minus 5.4 is equal to 0.6. Okay. Now we need to square those deviations. So we have 0.6 squared, and we should be getting 0.36. The last x value we have is 7. So we have 7 minus 5.4. which is equal to 1.6. We need to go ahead and square this value. 1.6 squared is equal to 2.56. We are done computing x minus x bar squared for each of the data values. Next, our formula says that we need to add all those square deviations, okay, which is what you see on the last row on our table. Here you're being asked to write the sum of the square deviations. So to find the sum of x minus x bar square, we need to go ahead and add all these values here. We need to take 5.76 plus 0.16 plus 0.36 plus 0.36 plus 2.56. If you add all those values, you should get 9.2. So now we have the value that should go on the numerator of our expression. So now we can come here and say s is equal to the square root of 9.2 divided by n minus 1. What is n here? Remember, n is the number of data values that you have. Our n value here is 5. You have 1, 2, 3, 4, 5 data values. So n here is 5. We are going to have 5 minus 1 on the denominator. Let's go ahead and simplify. This is equal to the square root of 2.2 divided by 4. Let's continue to simplify it. We have the square root of, what is 9.2 divided by 4? 9.2 divided by 4 is 2.3. We are almost done here. Go ahead and take the square root of 2.3 on your calculator. Look at that value and round to 2 decimal places. This is approximately 1.52. Again, here I'm rounding to 2 decimal places. That is your final answer. For this problem, we approximate the standard deviation of the sample to be 1.52. If we wanted the exact answer, we can write the square root of 2.3. Okay, that would be the exact answer. Once you round, you have an approximation. Now, here below, you have an exercise where you're going to be computing the standard deviation of a sample. Below this video, I'm going to be asking you to give me the deviation for the data value 72. So I'm going to ask you to give me this value. I'm also going to ask you to give me the square deviation for the data value x equal to 72. I'm also going to ask you to give me the sum of the square deviations. And finally, I'm going to ask you to give me an approximation of s. For this, you need to round your answer to 2 decimal places. Below these questions, I'm also going to be providing a solution. In order to access the solution, you're going to need to submit the assignment first. And when you go back and review your answers, you're going to be able to see a solution below the questions related to this problem.